Okay. Enough laughter. Okay. Let's look at what we know. The first thing we did in the course practically was this, wasn't it?
Yeah.
Where we got 3 data points and solved 3 simultaneous equations, right? You know, we got 3 data points by observing the water flow and stepping off our time with check marks and all that stuff, right?
Mm-hmm.
So we know this. And make sure you know this, okay? Because you're supposed to know this. It's probably going to be on that optional alternative midterm, in addition to all the stuff that was on it, okay?
Yeah.
Okay, so to solve that, you need 3 data points, right?
Mm-hmm.
Because you need 3 equations to find the values of your 3 parameters, right? If you only had 2 equations, you wouldn't be able to find your 3 parameters, right? It just wouldn't work. Just try it. Just take any 2 points and try to fit it into this and solve for A, B, and C. You won't be able to do it, okay? Now, if you had y equals mx plus b, and we didn't spend a lot of time doing it this way because we were concentrating on fundamental triangles and other meanings. But you could easily do it if you have 2 points. You plug them in and you get 2 equations. I mean, if you have an equation that has a y and an x in it, then you can always plug the coordinates of a point in and get an equation that it has to solve, right?
Mm-hmm.
Okay? So if we have 2 points, that's enough to find m and b. And you should be able to easily do that. It's very much like this, but shorter and easier. Okay? Now, we're going into exponential function. Now, what kind of function is this?
Quadratic.
It's a quadratic function. What kind of function is this?
Linear.
Okay, so we got linear functions, we got quadratic functions, and we studied both those in some detail. Okay? Now we have a 3rd class of functions, exponential functions. And the form is y equals a b to the x. Now, just a preview, there's also, we haven't done it yet,
Power functions. X to the base.
let's, yeah, that's bad rotation. We need the a. I don't know why I don't write the a there, because I know it has to be there. A equals x to the p. P is the power, okay? It looks almost like this one, but what's the difference?
You said A equals X to the P?
Let me quickly fix that. Because I wrote it down carelessly. Okay, this is y equals ax to the p. This is y equals ab to the x. What's the difference?
The x is
The x is the power.
Yeah, where's the x?
Yeah.
The x here is in the exponent, right?
Mm-hmm.
Making it making it your basic, an exponential function, okay? Where's x here? It's the base, right? And you're raising it to a power, so this is a power function. If p was 2, it would also be your basic quadratic function, right? Okay?
Yeah.
So, and you could do the same thing for this.
So is YAB kind of like y equals 2x?
It could be
2 to the
y
x?
equals 5 times 2 to the x
Okay.
for some functions. It could be a, 3 times 10 to the x, okay? It could be something times 1.483 to the x, all right?
But will it graph like 2 to the
It's always going to look like the 2 to the x graph
Okay.
if you relabel it appropriately. Sometimes you got to reflect it about the x-axis or the y-axis, okay? But it's going to pretty much look like that.
Okay.
When you say the power function, if it had 2, it would be the basic quadratic function. But wouldn't it be like the basic function with a stretch? Like that, because you said y, if it was y equals ax squared. That would be a basic quadratic, but the basic.
Yeah, well, your basic quadratic is just y
X
equals
squared.
x squared, so a would be 1, right?
the stretch, yeah.
But then you vertically stretch it and you got ax squared, right? If p was 3, you'd have, and a was 1, you'd have your basic cubing function, right? So you've seen two power functions. Now, you see, we're not ready to do the simultaneous equations for this,
Yeah.
okay? But you'd have two parameters, a and p, so you could do this if you had 2 points, right? You write down two equations. The problem is solving the two equations requires that you know something about exponential functions and the inverse of the exponential function. Just think the 2 to the x function and the inverse of the 2 to the x function, okay? Now, we're not there yet, but I'm trying to frame this. Okay, we also have, we have basically 4 classes of functions in this course. And then we have polynomial and rational functions that we get by combining power functions and combinations of power functions. We'll see that because that's coming up. Okay, we're going to kind of spread that out while we're also talking about exponential functions, because if we don't, it just confuses people badly. It might be confusing to be doing two things at once, but I think not. I think less so. We'll see if I'm right. Okay, the whole point is you can find A and B if you got 2 points, right? You can find A, B, and C if you got 3 points. You can find M and B if you've got 2 points. You can find A and P. A and P if you've got 2 points, right? Okay? So we're going to have to be able to solve the simultaneous equations for all these cases. Now, carelessly on problem 1, I said I left off the A. And I gave you 2 points. What do you think?
You need 2 points.
Okay, if you got y equals just b to the x, if I gave you 2 points, you'd have too many functions, or too many equations. Okay? With incompatible solutions. My bad on the cell 1 problem. Or was it the cell 2 problem?
Was it? Oh yeah, well, it was number 1.
Yeah. Because I just said A, I just said B to the X, okay? I'll blame it on the program, but I wrote the program and I put the problem into the program. So I guess really I'm kind of stuck.
You got it on that paper right there, the correction.